So for today, I am talking about adding and subtracting fractions. Like, seriously, we need to start with something like this. But honestly, these aren't the greatest because do you get on this kind, you could cheat and just multiply both of these by 2 and all of a sudden you've got a common denominator?
Yeah.
Do you get how quick that and easy that would be? Well, it's not going to be that quick and it's not going to be that easy. Over this way, you'd have to times by 2 and times by 2 and all of a sudden you've got a common denominator. They're not going to be that easy. So instead, I'd rather go off to the side, please, and add 2/3 plus 1/5. Why is that harder? Because you can't just multiply one thing and fix it. So this kind, though, we can have a system that will always work. You can just multiply by what I call the other denominator. Do you get, if I times by 3, it's the other denominator. You know what I mean? It came from over here. And if I multiply the other side by, what do you think? 5. It's the other denominator. And this will work even on those ones we had before. It would have worked. The numbers would just be bigger. But this system would work for all fractions. And I love systems that work for always. And otherwise, it's just a little trick that only works sometimes. That's not handy. All right, so let's finish this thing. Do you get this means I now have 5 times 2 is 10/15 plus 1 times 3 is 3/15, and that makes 13/15. Do you get how that worked? So you've got to be able to handle it with numbers because soon it's going to be things like x and x plus 1. And if you don't get it with numbers, you'll be toast. Let's do it one more time with some nastier numbers. 7/8 plus 1 1/3. Only one thing to do different here, and that's get them both to be fractions. What do you mean? They are both fractions. No, they're not. One of them's a mixed number. Do you remember how to make that into a fraction? It's these little things that sometimes come back to bite you. All right, well, I'm going to do it this way. Would you agree that 1 1/3 has a little plus in between it that you never say? Would you agree that's 1 1/3 means 1 plus 1/3? And then 1 could be thought of as 3/3, couldn't it? And now it's almost like its own little fraction problem. Do you agree that that's 4/3? Now, I know some of you did it a different way. Your 1 1/3, you changed it to 4/3 by going this times this plus that, but you probably don't know why you did that. And I think this way it shows you why you do it, because 1 is the same as 3/3. And then you add the 1/3 to it, and you get 4/3 either way. Okay, so now it's 7/8 plus 4/3. Multiply by the other denominator. So Brody, see this 8 here? I'm going to multiply that by the other denominator. So what do I put? There you go. Like that. David L., the other one. What goes here and here?
Times 8/8.
Correct. Now everybody simplify it down and tell me the answer. Chase, multiply across the top and change my answers so they have a common denominator. What is this one?
21.
21 what's? 24ths, good. Plus the other one. 32 24ths, good. And then add them both together. 53 24ths. Now a lot of people ask, do you have to make that into a mixed number? No, you do not. I hate the word improper fraction because it makes it sound like we should fix it, and it's good the way it is. The reason? You will never see 1 1/2 m in a problem, for example. Never ever. You would see 3/2m. You can see that, but you'll never see 1 1/2 m. And this is algebra, and algebra is used in our class all the time. So you would leave it like this. You would not make it 1 and some fraction. All right. All right, moving on. Let's get back to this. All of a sudden, they got nasty. That's what we were preparing for, is that they're fractions, but now all of a sudden they got variables in them. Well, we can use that system I just showed you a second ago. But this page is just meant to remind you, if they have a common denominator, it's really not that bad. Do you get they already have a common denominator? So then you just, what? Do you actually add the denominators together? No. No, you leave the denominator as x squared plus 3x, and you add the tops. Careful. X squared and x squared makes 2x squared. Negative 2x plus an x makes minus x. And you might think you were done right there, but you're not. If I tell you that, can anybody figure out what the final answer is? Don't say it. When you realize, you'd be like, oh yeah, I can do this. I know you're not all stuck, but there's a bunch of people stuck, and you should be thinking, Mr. Server always says, if everybody's stuck, to think about factoring. Do you get that this thing can factor? Do you get there's an x that comes out of the top? And there's an x that comes out of the bottom? And that means that that can cancel. All right, what's left? 2x minus 1 and x plus 3. And then those cancel. I think I did it right. Raise your hand if you beat me to it. Raise your hand if you beat me to it. Okay. I understand you wanted to interrupt and say something, but I needed to finish that problem. Okay, and there's a chance I did that wrong, but I'm going to pause for a second and let you guys think. Okay, we've agreed that this is the right final answer for that one. Okay, so now I'm going to go on to this one, which adds a twist. You would think, like, denominators are the same. That's going to be easy. But it adds a little twist, and a lot of people are going to screw it up. So I'm going to just say, try your best and try not to fall into the hole. I'm going to pause for a second while you try that one. All right, let's see if you fell into the hole. Did you know that the 4x and this negative 2x together make 2x? How many of you caught that? Okay, good. Now, did you fall into the hole, though? Because negative 1 goes with negative 9, which makes positive 9 and makes plus 8. Raise your hand if you had that part right. Cool. If you say what, that means you didn't catch that. Okay. Then, did you notice that that factors again? And some people fell into that hole because that cancels off. Boom, boom, the answer's 2. Anybody actually catch that all the way? Nice. Not many people. See how it's always about factoring? All right, now, how did that negative work? Let me explain more about how that negative worked. When there's a negative right here, do you think it just means that you're supposed to subtract the first thing that it sees? No. It means the opposite of that. I'm going to put in those parentheses, and I think that's the best way to keep from making that mistake, is to put in what are called implied parentheses. Implied means it's assumed that it's there, but it's not there. You can put them in anytime you want to. On a fraction, you can put the implied parentheses here. Now, in this case, that doesn't feel like it helps me that much to put it around the x minus plus 4s, but you could. All right, hold on just a second. Back to this. Okay, so where is there other implied parentheses? These. But again, they won't matter that much. Out of all these parentheses, only this one, these guys that were around this, they actually mattered because this negative will get distributed then to both things. All right, everybody move on to the next page. Problem 3 on the bluish colored, I don't know, is that blue or is that green or what color is that?
That's blue.
Okay, light blue. Anyways, do you get that we have to multiply by the other denominator to get a common denominator? I'm going to just scribble out this problem 3 here. So the other denominator, let me think. The other denominator would be x plus 2. And the other denominator from this price perspective would be x minus 3. And now, remember me talking about those implied parentheses? There's parentheses around this. There's parentheses around that. So it matters. Now, next thing, the kind of the corollary to, like, if you can factor it, you should, is don't multiply out things that are already factored. Otherwise, you're just going to have to refactor it again. So leave the denominator with x minus 3 and x plus 2. Otherwise, you're going to do all this work, multiply it out, and then what do? You factor it again at the end. So don't do that. Just don't multiply those out. Otherwise, you're just going to have to refactor it later. Then, with these implied parentheses, right here, these are key ones. I forgot those last hour. And then I only multiplied the 1 in there, and that's wrong, obviously. You need those implied parentheses, because now it's a binomial, this thing here, times another binomial, that thing there, and you do the first outside, inside, last thing to get your answers. That all of a sudden steps it up a lot. But at least we have a system, multiply by the other denominator. All right, now simplify that down as much as you can. Remember, the denominator looks like this. You don't want to multiply it out. Otherwise, you'd have to refactor it again. Once you're all done, take your time. Once you're all done, look up and see if you got the same thing as me. If you got the same thing as me without looking at my answer first, please raise your hand so I can verify that I think I did it right. That many kids, it's probably right. Cool. And I tried last hour. I could not figure out any way to factor this further. Do you get if I could have factored it, then something might have canceled? So if you can factor it, you should. But I just can't in this case, so I guess I'm done.
You just don't multiply the denominator any?
No. And the reason is because if I did multiply it out, then how would I end? By factoring. Because if you can factor, you should. Do you get if I do multiply this out and I get an x squared, and I'll just show you what I would get. Minus 3 and the plus 2 makes minus 1x, and then minus 3 times 2 is 6. You can't ever cancel anything when it's in this form anyways, because it adds and subtracts. You know what I mean? You can never cancel things like that. So even if something did match the top, I wouldn't be able to cancel it unless it was factored. That'd be kind of like this. Let's say I factor it and I get this. Can I just cancel the x squareds in that case? No, because it's part of an add problem. So you don't want to make them like that. You want to make them factored if you can. So don't do that. Okay, to the next page. Problem 5 is our first, really weird one. Because the number 10 there, it isn't even a fraction. And somehow we're supposed to get common denominators and add it all together? Yes, now it's a fraction when you put it over 1. And now we can follow the system. Which is multiply by the what? The other denominator. And if you go to the other side, you'll realize, should I times them by 1? And then you'll be like, well, I guess times by 1 doesn't really do anything, so the system works.
0 on the bottom there?
I think you're thinking that when you have two fractions, let's make it simpler again to understand it. Let's add 1/7 and 2/7. If I subtracted those, would I really subtract the denominators?
Oh, no.
No. You wouldn't leave. You'd leave the denominators alone, right?
Sorry.
Okay, no problem. It's a very common misconception, so I'm glad you brought it up. Somebody else probably was thinking it. So the denominator is still the denominator, x squared minus 2x minus 4. In fact, I should think about factoring it, but I'm pretty sure it doesn't factor. If you can beat me and actually factor it, awesome, but I don't think so. And then on the top, that has to get multiplied out. 10x squared minus 20x minus 40. Now, how come you're multiplying that out? Because I have to add it to these other terms over here, the 2x plus 1. And I'm going to just on purpose make a huge mistake. Plus 2x plus 1.
Negative.
It is a negative, and I'm not going to make another huge mistake. Oh, it was minus. There. Now it's minus 2x plus 1. What's wrong with that? You'd need a parenthesis so that it's negative 2x minus 1. Why? Because there were implied parentheses up here. All this little algebra really matters a lot. Now, the fact that the bottom one doesn't factor tells me that there's no point in factoring the top because nothing can cancel. You know what I mean? Unless I can get the top to have an x squared minus 2x minus 4 in it, like if that's in the top, if that's a factor of the top. But bottom line, you can't factor the top or the bottom in this case, so it's pretty clear. I'm done. Without seeing my answer, did anybody get the same thing as me? All right, good. Okay, now this one, you remember my favorite saying, right? Can factor it. You should. Factor this before you get the common denominator. Factor it. I'll show you why. Oh, the bottom of that thing factors into x plus 3 and x minus 3. Why would that matter? Well, look at the other denominator. Now, this is one of those moments where the standard thing is multiply by the other denominator. But if I do, this is going to be a huge answer, and I don't like it. So, is there any smart way to do it? Yeah, there is. Only multiply one of them by something. Can you figure out which of the two fractions can be multiplied by something so that they'll have a common denominator? I mean, if you have to, then you would have to do the other system, but multiply by the other denominator. But there's a shortcut. I think Cole may have figured it out.
Can't you just multiply the right fraction by x plus 3?
You got it. Because look at them now. Don't they have the same denominator? There's implied parentheses right there. Now, don't they have the same denominator? Yup, and that was the whole point. So this way was just way faster. The other way would have worked, but you'd be multiplying for like 5 minutes to get the thing all multiplied out. This was way easier. And what did it come down to? If you can factor it, you should. That's going to happen on your homework too. There'll be one where if you would have factored it ahead of time, you would have noticed, oh, I don't actually have to multiply both sides by something. I can just multiply one of them by something just right. to make it have a common denominator. All right, you have made it through. This is the part where we go to your homework. You are going to be skipping problems 8, 9, and 10. There are 12 questions, but I think you're going to find that with skipping problems 8, 9, and 10, you'll probably be able to finish before you even leave today, which is actually not really that good for you because doing a little bit of homework tonight makes it stick better in your brain, but I know most of you would rather just get it over with. All right. Now, can you read me number 1 of the homework? Okay, no problem. I'll come back to you for number 2. Madeline, can you tell me number 1?
2 over x minus 1 over x plus 3.
Awesome. Well, the standard deal is multiply by the other denominator. I think that's going to work here. Cool. What should I multiply the left fraction by?
X plus 3.
Correct. On the top and the bottom. Richens, the other fraction needs to be multiplied by?
X.
Yep. Now the denominator, keep it factored. I know it's tempting to distribute that out, but don't. It's not illegal, but at the end of the problem, you're going to have to say, did you factor it all the way to see if something would cancel? So why would you want to multiply that out? You just have to go back and refactor it. So then we got the 2x plus the 6 minus an x. And then you may as well just put that all together and not write a whole new step. 2x minus the x would make x. I got x plus 6 over x times x plus 3. Did you guys get the same thing? I think it's right. Yep. A bunch of people are nodding. All right. I think you got the idea. There's always going to be a twist. So, of course, later in the assignment, there'll probably be something that's a little weird. You can always look at the key if you want to, or come up and ask me for help. And that's all I got for the video for today.